In the last lecture, we learned about local references. Now, there is also another way of getting access to local references or to any element actually directly from within our TypeScript code. Right now, we're passing the reference here when we call a method, and that works fine. But sometimes you want to get access before we call the method. And there is a nice little decorator we can use in TypeScript to get this access. Let's do the same for the server content. So here I will quickly duplicate that input and comment out the old solution using two-way binding. And the new solution will not use two-way binding, but instead this will now also have a local reference, the server content input maybe. Now in the cockpit component, I will also comment out the old new server content here. And I will add a new property which I'll name server content input. Now server content input like this is just a property, but we can add viewchild in front of it, this decorator with parentheses, and we need to import viewchild from @Angular core. Now viewchild like this won't work. We need to pass an argument here. And this argument actually is the selector of the element, how we want to select the element. And selector now not like a CSS selector, but for example, we can simply pass as a string the name of a local reference. So server content input could now be passed as a string. If you don't want to pass a string but want to select a component, you could simply pass the component type here. So in the cockpit we don't use any other components, but in the app component we could pass cockpit component, so the type like this, not like a string, to get access to the first occurrence of this cockpit component in the app component. But here I'll switch this back to getting access to the local reference, which probably is the use case you'll see the most often. And with that, we now get access to our server content input. Now, what does this actually hold then? Let's quickly comment out this code so that it doesn't break. And let's log this server content input. So our property here, which is kind of set through viewchild. So with this, if I also comment this out down here so that we can run our app, and if I now save this and we go back to our application and I enter something here and I click add server, we see that this is of type element ref. So unlike the local reference we passed directly from the template via the method, which was the element itself, this is of type element ref. So we can set this type here, element ref, a reference to that element. Element ref needs to be imported from @Angular core. It's an Angular type. So this element ref, however, has a useful property we can use, and that's the native element property. We can use server content, this server content input here, and then native element to get access to the underlying element, which now has a value because this will now be the input element. Now we can do the same, of course, for the onAddBlueprint method. And with this, we get direct access to elements in our DOM, in our template, through @viewchild. And you should see that this now works again if we enter some content here and click the buttons. Works perfectly, now without two-way binding, but with local references passed to methods or local references fetched through viewchild. Now one important thing to watch out for is you should not change the element through this. Because of course you could use our server content input, the native element, and then set value to something, right? You can't do this. And if we actually do this like this and I click add server blueprint, you see something was now added here. I strongly recommend not doing this. You should not access the DOM like this. Angular offers you a better way of accessing the DOM, and you will learn about this in the directives section. Generally, you should use the other tools like string interpolation and property binding if you want to output something in the DOM, and not directly mess with any elements you can get, even though if you have gotten them through Angular. So we learned a lot throughout this section. We learned how to pass data around, how to get access to elements in our DOM, how to use local references. So our application now is much more dynamic. We got much more tools to interact between the different pieces we have in our app. Now, there is another way we can pass data around, the last way for now. In our server element component here, right now we check if we have a type server or a type blueprint server, right? Nothing wrong with that, but sometimes you have complex HTML code like this, which you want to pass into a component from outside. So imagine you don't want to set this up inside the component here. I cut it. Instead, in the app component, you somehow want to add this here between the opening and closing element of your own component. And there we simply would have to replace element with server element. And we should expect this to work, right? So if we save this and let it reload and we add a new server, we don't get an error, but the content is also not there. And that is the default behavior. Everything you place between the opening and closing tag of your own component is lost by default, is simply removed from the DOM. Angular will not take care about it. But you can change this. There is a special directive, and it is a directive even though it looks like a component, but it doesn't have its own template. A special directive you can add in the server element components template here. In the place where I want to render the content, I can add ng content. Opening and closing, again, it still is a directive, just using this element-like selector. And this serves as a hook you can place in your component to mark the place for Angular where it should add any content it finds between the opening and closing tag here. So this content in this case. With this tiny addition, you should see that once you save this and let it reload, if we add this and we click Add Server, you now see the content is back. It looks exactly the way it looked before, but technically something totally different works or happens here. Now we add this via the ng content hook. We add it between the opening and closing tags, and therefore it will be projected into your component, projected into your server element component. A nice feature, especially if you think about building reusable widgets, like a tab widget, where each tab will have a content which probably comes from some other source and which you don't want to pass through property binding, which always would be an alternative. But if it's more complex HTML code, property binding really is not the best solution because Angular will escape HTML tags there to prevent cross-site scripting attacks from happening, and you could kind of work around that, but really ng content then is how you want to display this, and that is a great tool to have at your disposal. Whew. We're nearing the end of this section, but there's one thing you might have recognized before where you weren't sure what it does. What's up with this ng-on-init method we have in new components created through the CLI? What's it doing? ng-on-init is a lifecycle hook, and Angular supports a couple of lifecycle hooks. Let's take a closer look. If a new component is created in Angular, and of course Angular is responsible for creating these components, when it finds one of our selectors, for example, it will instantiate a new version of that component and add it into the DOM. So once a new component is instantiated, Angular goes through a couple of different phases in this creation process. And it will actually give us a chance to hook into these phases and execute some code. We can hook into these phases by implementing some methods Angular will call if they are present. The first phase, the first hook we can hook into is ng-on-changes, and this may actually be executed multiple times. It's executed right at the start when a new component is created, but thereafter it's also always called whenever one of our bound input properties changes. And with that I mean properties decorated with @input. So whenever these properties receive new values. Now the second hook is ng-on-init. This method gets executed once the component has been initialized. This does not mean that we can see it. It has not been added to the DOM yet, so to say. It has not been displayed yet. But Angular finished the basic initialization. Our properties can now be accessed and initialized, for example. So the object was created, you could say. And if you're interested, ng on init will run after the constructor. Then we have ng-do-check. That will also run multiple times. Actually, this method will be executed a lot because this will run whenever change detection runs. Now, change detection simply is the system by which Angular determines whether something changed on the template of a component, or inside of a component, I should say. So whether it needs to change something in the template. So whether some property value changed from 1 to 2, let's say, and that property is output in the template. Well, of course, Angular needs to re-render that part of the template. And ng-do-check is a hook executed on every check Angular makes. Now, important, on every check. So not just if something changed. A lot of times ng-do-check will run because you clicked some button which doesn't change anything, but still it's an event, and on events Angular has to check if something changed, because how else would it know? You don't tell it, right? So it has to check on certain triggering events, like you clicked somewhere, or a timer fired, or an observable was resolved. And on these occasions, it will check your code and ng-do-check will be executed. Now, whilst this might sound very inefficient, Angular does this in a very efficient way, so change detection Angular works pretty great and doesn't cost a lot of performance. ng-do-check is a great method to use if you want to do something on every change detection cycle, like maybe manually inform Angular about some change it would not be able to detect otherwise, though that is a very advanced use case. Well, then we reach after content init. This is called whenever the content which is projected via ng-content has been initialized. So not the view of the component itself, but instead you could say the view of the parent component, especially the part which will get added to our component through ng-content. And ng after content checked is executed whenever change detection checked this content we're projecting into our component. ng after view init is then reached once the view of our own component has been finished initializing. So once our view has been rendered, you could say. And the same after view checked, well, that is called whenever our view has been checked. So once we are sure that, well, either all changes which had to be done were displayed in the view or no changes were detected by Angular. And finally, if you destroy a component, for example, if you placed ng-if on it and this gets then set to false and therefore it removes it from the DOM, ng-on-destroy is called. And here's a great place to do some cleanup work because this is called right before the object itself will be destroyed by Angular. These are the hooks. Nice to see them in theory. Let's see them in practice in the next lecture.